This is part 2 of the Greenfoot game practice test where we're making asteroids. So in part 1 of the video, which if you haven't seen, you should go back and watch that thing if you need it, we have the following functionality. We've made a ship actor in Greenfoot, and using the arrow keys, we can control the ship and move it around the screen. It has a real floaty, kind of cool effect feel to it. So we're going to continue with step 5. So in step 5, our goal is to make the ship fire bullets. So let's go ahead and add a bullet actor and set its image to the bullet.png file from our resources. So go ahead and right-click actor, do a subclass, we'll call this bullet. And for the image, select the bullet image from where you downloaded the project images. Here's mine, bullet, on my desktop. Okay, cool. Say OK, and we're good there. All right, so next up. A constructor in Java is a specialized method that has no return type and has the same name as its class. And it's run whenever you create an object. In fact, let me show you what I'm talking about. Under Asteroid World, we already made a ship, right? Right here. We said ship, and this could have been any name, like Bob, if you wanted to. Let's just do this just to be clear. That this is a variable name, and this is a class name. So Bob is a chosen name, but ship is the kind of object it is. So ship Bob, when you said new ship, this is the constructor. You were calling Bob's constructor. And for a ship, I don't think there was any constructor in there, to be honest with you. So in this code, you don't actually see a constructor because what Java does, if you don't specify a constructor, by default, Java puts one in there for you. So really, here's what Java did. Public ship, and then no parameters, and basically do nothing inside. So this is a default constructor that Java provides for you, but you just don't see. Now sometimes you want to add code to these things. And for the bullet, that's what we want to do. We want to add our own default constructor where we actually have code that runs specialized stuff inside of this function. But a constructor is just a method that has the same name as a class, so ship, and then this class name is also ship, and there's no return type. So you don't say void, you don't say integer, or whatever you want. You just public the class name, and then you can have parameters. That's your choice. But this here is a constructor. But for the ship, we don't need it. Java will just provide its default constructor for us, and that's sufficient. So for bullet, let's go ahead and go to the bullet code. Let me resize my window so I can see what's going on. All right, for our bullet class, we do want to add a default constructor. So since we're inside a class named bullet, our constructor has to be named the same thing. So we'll say public bullet, get some parentheses in there, or braces, and whatever code we type here, stuff, this stuff will be run whenever a bullet is first created. So it's a really good spot to put initial setup code. That's what it's really for. So for us, let's see, add the following to the constructor. Actually, all right, fair. It's giving you the constructor here. So instead of a default constructor that has no parameters, we would like to have a parameter of you pass in an angle. So I'm going to go ahead and just copy this whole thing here. And instead of a default constructor, we're going to have one that has a parameter of an angle. So there's that guy. All right, so inside this constructor, our goal is to set the bullet's direction to angle. And we know how to do this already by doing set rotation. We had tried it with the ship before. So currently my Chrome is crashing. I can see that the page is black. All right, there you go. All right, so back to the actor class. The function that will help us initialize the angle of the actor is called set rotation. And so that's what we want to do. We want to set the angle of this actor to whatever the person passes in. So we're going to use set rotation. So here's our bullet code. And we're going to say set rotation. And we're going to set it to whatever this parameter is, we'll set it to that. I'm going to get rid of everything else here. So that's the only thing to do. So when a bullet is first created, its angle will be whatever we choose and pass in as a parameter. All right, next, add a global variable int speed to keep track of the bullet's speed. All right, so up here, not here, but remember inside the actual braces for the class, we'll add int speed as a global variable. All right, then inside the bullet's act method, tell the bullet to move by speed amount. All right, no problem there. So we'll say move by speed amount. Remember, move is a function that actors can do. So we'll say move and then pass in the speed. So this will move the bullet in whatever direction it's facing. When a bullet goes to act, it'll move in its current direction by this much. If you say speed is 5, it'll move by 5 units every time. If you say 50, it'll move much faster. So speed will control how fast the bullet is. I'm suggesting a value of 3 to start with. You can change it to whatever you want, but I'm going to go ahead and stick with a recommendation of 3 for now. So put what you want there, test out what you want. All right, next up, for step 6, let's go back to the ship code. And it says add code so that whenever the person presses space, the sound bullet.wave plays, and a new bullet object is added to the world with the same location as the ship. So let's do this one at a time. All right, first of all, let's go ahead and add code that when you press space, the bullet.wave sound is played. So in our ship code, let me find that. So here's my ship. Inside this code, we already have if the person presses other things. So we'll simply add down here if the person's pressing space. All right, so if the user presses space, we would like to play a sound. To play a sound, you have a few different options in Greenfoot. One of them is you could use Greenfoot sound and create a Greenfoot sound object. And then once you've created the sound from the file name, you could ask it to play. That's one option. A second option, which I'm going to use, is in the Greenfoot class, there's a helper function in here to play a sound. And it's called play sound. So since this is static, remember static means you can say the class name Greenfoot and then dot whatever function. So for us, Greenfoot dot play sound, and you pass in the file name. So I'm going to say Greenfoot dot play sound, and for the file, it was called bullet.wave. So check. Now for files, Greenfoot needs to know where the sound files are. So if you go to your project folder, let me go to mine. Mine's on my desktop. So here's my desktop. And my project folder is called Asteroids right here. Inside the project folder, you have images where we have the space image shape, the ship and the bullet, but you also have sounds. So inside the sounds is nothing. You need to drag um, the right sound. So bullet.wave, in fact, let's do all of them right now. So there's bullet, explosion, and game over. All of these need to be inside our sound folder. So let's go ahead and copy these into this folder. And now each of these sounds is accessible when we run the game. So if you haven't done so, go ahead and drag the sounds into your sound folder in your project. All right, back to our code. So now that we have that, in the asteroid world code, in the ship's code, go to ship. So when the person presses space, this will now play because Greenfoot will look for sounds inside the sounds folder. Let's go ahead and test this out and make sure this actually works. So compile, things are good. Back to the overall class. So if I hit compile, you can't see it because my screen is smaller than what you can see, but if I run it and I press space, you can't hear it, but it is firing. And so far so good. All right, back to our goal sheet. So we have bullet sound playing. That's cool. Next, add a new bullet object to the world at the same location as the ship. So this means two things. First, create a bullet object, and then add it to the world wherever the ship is. So this will be done in our ship code. So again, open up your ship code. So far we've played a bullet sound. Cool. Now we have to actually create a bullet. So to create an actor, in this case a bullet, it's always the same pattern. You say the object name, bullet, name it. I'll call it bullet, but you can name it anything. Here I'll call it Sam. Bullet Sam equals new bullet. That creates the object. Now, after creating the object, we need to add it to the world. But the thing is, only a world can add objects. So you can't just say add object because if you did, you're an actor. A ship is an actor, and actors cannot do add object. Only worlds can. So first we'll have to say get our worlds. That'll return the world we're in, and then the world can add the object. So we want to add object Sam at position the same spot as the actor. So to find out our own x and y position, we'll say get x and get y. That's our current actor position. And that'll add an object of a bullet type to our current position. Then, let's see, I forgot. When creating a bullet, remember, you can do this, but we had a special constructor. Remember in bullet, let me open this up for a second. We have this constructor that accepts an angle. So let's go ahead and pass in the angle of the ship into the bullet. So the bullet's already facing the right direction. So in our ship code, we want to pass in the angle of the ship. Now, how do you find out the angle of a ship? Well, since a ship is an actor, a ship can do all the actor things. So if we look at the actor API, there's got to be a way to find out our current angle. So under actor, let's look for a function that can return our angle. Here, get rotation. So if we call get rotation, that will return our current angle, and then the bullet can use that. All right, so back to ship. So when we say new bullet, let's also do get rotation, and this will give the bullet our current angle of the ship. And then from there, it's good. So I think that's it for that particular part. Let's see. Done, done, done. Yep, I believe so. So let's test out part 6 and see if this actually works. I'm hitting compile, running. Cool. So if I hold down space, it creates this huge stream. So while that looks totally awesome, this is way too many bullets. I mean, really, that's just it. If you want it, I guess you can keep it. But to me, that's too many bullets. So it's like a power up right there. So let's slow down the bullets. That's step 6 to slow things down. Or step 7. So in step 7, it says pressing space fires way too many bullets. I personally agree. You may not. But to slow down the firing rate, let's create a counter variable in the ship code. And whenever the counter is below 20, pressing space has no effect whatsoever. You have to wait till the counter reaches 20 or more. Then if the person presses space, it's cool to fire a bullet and then reset the counter back to 0. So all this is done inside of our spaceship code. So open the ship code. Now let's add a counter to count act steps. So we already have variables for speed. Now let's do integer counter equals 0 to start with. And every time the ship goes to act, we're going to increase the counter, counter plus plus. And here, if the person's pressing space, we don't really care unless the counter has reached 20. So above this, we're going to say if counter is 20 or more, then we care about doing all this stuff. So let's indent this. And way better. So only if the counter is 20 or more will we actually allow a bullet to fire. And once it does fire, we'll make sure that we reset the counter back to 0. That way it can reach 20 again. So counter equals 0. Make sure you reset this, otherwise you'll get one bullet completely and nothing else. So let's compile this and try this out. All right, that's much better. So now bullets are spaced out, I think, in a more appropriate way. And you can adjust the counters of 20. You can make that higher or lower depending on whatever firing rate you want. In fact, it'd be a great idea. I didn't do it in the video, but instead of hard coding 20 there, really on the instructions it doesn't say so, but you probably should put like firing rate. Firing, let's see, fire, how about fire speed? That's a way better code style. So up here, we'll make integer fire speed equal to 20 for now. You can change it up here just the once. So the code works the same. And now we have a ship moving around and firing bullets, which is pretty awesome. All right, next up. Step 8, add code so when the ship goes off the screen, it appears on the opposite side. What we mean is this. Let's say the ship goes off the screen here. Well, it should then pop back up on the opposite side way down here. Or if it goes off the screen over here, pop up on the opposite side over here. So to do this, I assume you've done it on your own or tried. And so really this is just kind of checking in. So I'm going to go ahead and put this, let's see, we have to decide where to put this. So for sure in the act method, let's go ahead and say, let's do this after set location. So once we've updated the location, let's go ahead and check with that location and say if the X location is below 0, that means you have gone off the left edge of the screen over here. So if you go below 0, we should pop up at the opposite side over there. So if the X position of our actor is below 0, then we would like to say set location to the opposite side. So how about get worlds? That'll get the world, then got get width. That'll work out. So check. Then for the Y position, it'll be the same as it was before. So get Y. So what this will do is if the actor goes off the screen below 0 on this side, it will pop back up at the width of the world, but the height will be the same. So the Y value will still be this height, but it'll be popping up over here. So you'll wrap around from left side to right side. And so this idea just gets repeated for all the different sides of the world. So there's one side. And the opposite, if getX is greater than the world's width, so let's go ahead and copy our code to grab the width of the world. So if we're above the width of the world, then set the location for X back to 0, and the Y just stays the same. So in this case, if we go beyond the right edge of the world, go back to 0. And that makes it so that if your ship goes off the edge to the right, it pops back up at 0 and keeps going with the same Y coordinate. All right, so let's just copy these lines here and do the same for the Y direction. So pasting in, if the Y coordinate is below 0, let's set it to the height of the world, and the X position will be the same. So X stays the same, but the Y position will be on the other side. And same thing here. If the Y position is beyond the height of the screen, we're going to say the X position stays the same, but the Y position will go back to 0. All right, let's go ahead and test this code out. So I'm going to compile my code. You're not going to be able to see the entire thing because I can't fit the whole screen on here, but I can show you at least this portion here. So let me go ahead and run my code. All right, if I go off the screen, cool, it's popping up. So notice, now test all 4 sides. If I go to the top, then it pops out the bottom. And so it's working perfectly. It's pretty cool. So if you have this working, your ship, pops out from one side to the other, and it's pretty cool. All right, so we've got that working. All right, next up, so we've done step 8, and I think I'll end this video here. So we'll continue in the next video with step 9. So see you then.